Again to introduce Paitra. Onkst? Yeah, she is one of our undergrad students also. She's a very thorough student, I could say again. And, this work that she's reporting is actually very preliminary, so I don't know the story, so this is something that will unfold in the coming times. But she studied well, and it's promising.
So mine is similar to Jane's, where I'm looking at biologically active chemicals, but I'm looking at them in the neem plant. The neem plant is actually a tree found in the continents of Africa and Asia. These samples that I got were from Nairobi province in Kenya. Dr. Mwebe brought them back for me. Many people use them in traditional medicine, like the Ayurvedic, which is traditional Indian medicine, Unani, which is like South Asian, related to Hippocratic medicine, and homeopathy. There is also used in commercial pesticides to find something that is biodegradable and works well with the environment. But there's more than 140 different chemicals that have been found in this, that are found and useful in the neem plant. Some other research that's been done has been cancer treatments for oral cancers, as well as melanomas and spleen cancers using the leaf. That's what other researchers were looking at, as well as doing liver stimulation, which also is being done with the leaf. But in traditional medicine, the treatments that they use it for include reducing inflammation, taking care of infections, fever, skin diseases, dental disorders, and they use all the different parts of the tree, the leaves, the flower, the seeds, the roots, the bark, every bit of the tree. They chew it, they'll brew tea with it. So that, again, that's part of what how my study is different, in the fact that I'm looking also for the antioxidant and phenolic compounds and how much is there, but also where they're found, as in the leaves, the bark, the stems, where particularly are these chemicals found. And also to discover how you process it, if you brew it in a tea, if you powder it and then consume it, makes a difference in the amount of chemicals that you have, the benefit that you receive. First of all, how I ended up, when I got these samples, they had been frozen, so I took the frozen samples and I wanted to get as much of the surrounding liquid off of them, so I let them thaw, patted them dry, and then for ease in processing and dividing of samples, we cut them up and shredded them. And the two methods that I focused on as far as processing were just air drying in a normal room temperature, and also freeze drying it. To air dry it, I laid the samples out in the lab. I covered them so they wouldn't be contaminated, kept them at, like I said, approximately room temperature, 23 degrees. And every day I would go in and move the leaves around and stir them so that they would dry evenly. And the bark and the twigs, every sample I did the same thing for. For freeze drying, I sealed them inside beakers with parafilm, put them in minus 180 degrees, and then put them in a levelizer, which is a freeze dryer, to complete the process. To extract my samples and get the compounds out so that I could analyze them, I made an aqueous ethanol solution, which is 80% ethanol, 20% water. I poured 10 milliliters of it in a vial with portioned out of my sample. For my leaves, I used about half a gram. And then I put it on a shaker for 24 hours. After 24 hours lapsed, I poured the liquid off of it. Fortunately, I didn't have to centrifuge because my solid sample is all at the bottom. But I decanted the liquid off and then put another 10 milliliters of my aqueous ethanol in there, put it back on the shaker for 24 hours, and did this for 3 consecutive days. Because I wanted to see if by extracting multiple times you get more, or if you get most of it on your first extraction, and how that related. To analyze the extract, I used the FRAP method, which reduces iron, an iron 3 TPTZ complex to an iron 2 TPTZ complex. To do this, to make the FRAP, to make my sample, I used 2.6 milliliters of FRAP with 300 microliters of my solvent and 100 microliters of my sample. I only used 100 microliters of my sample because if I used more, I got too much noise and my results were not meaningful. So I had to actually dilute, and I diluted with my solvent. To prepare a frap, you use an acetic buffer, which is an acid with a pH of 3. And then I used 2,4,6 tripyridyl S-triazine in 4 milliliter hydrochloric acid mixed with iron 3 chloride. And the reason you use that is what antioxidants do in your body and everywhere is to reduce free radicals. They reduce free radicals by giving up an electron themselves and therefore keep the radicals from reacting in your body. That's how an antioxidant works. So what the antioxidants would do would be to take that iron chloride from iron 3 chloride to iron 2 chloride in the complex. And you measure that at 595. That's where you look for those. I found that 66% of the active antioxidants were extracted within the first 24 hours of my 3 pours. The way I figured that was to take at the highest peak, because it would be about similar, but the highest peak, the highest value, and I totaled that out and added it together. So like on the first day, at my 10-minute mark, I had like 0.77 on my highest peak. My second day was like 0.23, and my third day was 0.16 for a total of 1.6. So when you do the math, it gives you 66% extraction on your first day of your active compounds, 20% on your second day, and 14% on your third. And time does make a difference. Like the longer I gave it to react, the more it did react. I did actually go longer to see exactly how much it would react, but found that pretty much at 10 minutes, 99% of it had reacted. After 10 minutes, it was pretty much negligible, so there's no point in taking it further than that. In average absorbance for 4 different samples of leaves, it was pretty close as far as they weren't, one sample versus another sample was not truly significantly different. It kind of looks like that on this scale, but when you actually look at the difference, it's only a difference of 0.2 And for my bark as well, again, it was pretty close, although it was only a difference of 0.03 between my lowest and my highest. So again, pretty consistent. Although if you compare the two, the amount of antioxidants in my leaves compared to my bark, there's almost 3 times as much in the leaves as there was in the bark. So again, there's significant amounts of the antioxidants because with the baselines that I was getting, my baselines were like negligible and I was showing reactions, and then the leaves were found in higher levels of antioxidants, like I said, 3 times more than what was in the bark. My future work, I have twigs and stems where I'd taken the bark off the stems to assess the bark separately from the stems, so I still have those to process. And also determine those were all the samples that you saw were done with air drying, so I still have to process my freeze drying samples and see where that will take me. And then I'm also going to employ the same Folin, Chicalto, and use the HPLC and the GCMS to see exactly what I have and how much I have, and looking for flavonoids. And I'd like to thank Andrew Wood, who every time I had an emergency took care of my research, and Dr. Mwebe for having confidence in me, and Ms. Mosier because she's the one who found the research for me. I don't even think I'd be standing here but for her. Thank you. Any questions?